Santosh, I think we'll start now.
Yeah.
So, good evening, everyone. This is Sudhir from Phovesto Powers Private Limited. I am the founder of Phovesto Group, and I was accompanied with Mr. Santosh, CEO of our Phovesto Powers division. And this is the webinar which is being conducted on microgrids, sponsored by Adhiyamaan College of Engineering, Department of Mechanical Engineering, and coordinated by Professor Shailin Juice. So today we are going to see about a microgrid, and I hope you will enjoy this time. So today we are going to cover what is a microgrid and what are all the nomenclatures we use in a microgrid, how the microgrid functions and the components in microgrids, the applications to it, limitations, as well as the opportunities you can look forward in a microgrid projects. So these are the things which we will cover today, and I'll proceed with that. And Mr. Santosh uh, is one of the CEO in Postopers. We happen to work in microgrids across the globe in Australia, US, UK, all those places, and we happen to come out and we happen to start our own division of powers in 2018, incorporated as private limited, and we happen to start delivering solutions in wide range of power plants such as solar, wind, microgrids, combined heat and heat generation plants, CHP plants, DG sets, all those things. So our objective is just to provide a sustainable lifestyle. So that is the since energy is a key. Since as we are speaking now, we are paying for the energy. So energy is a key for the growth of human civilization. So we want to make it a sustainable way, and our vision is to be the pioneers in energy power plant design and installation. We want to make our plants the most reliable plants on the planet. And our solutions covers from renewable, conventional energy storage, hybrid power plants, in large capacity in all the segments, residential, commercial, as well as industrial, defense projects, all the areas where you use electricity, we can deliver you our solutions. So coming to today's topic, microgrids. I think Mr. Santosh will take over the introduction to microgrids.
Hi, good evening to all. This is Santosh from Phovesto Power. So I'm the CEO of the company. Today I'm going to the direct section of the microgrid. Today we can directly go to the microgrid section. So microgrid mean what is microgrid actually? So we want to understand the microgrid mean. It's completely it's interconnected between distributed energy sources and loads and energy storage. So this is the microgrids actually. So why it's a microgrids required actually? So in India we are facing lot of the power issues actually like villages and colleges. So that is we will have still power actually. So with microgrid we can help to them to give the 24/7 365 days. So that's the beauty of the microgrid actually. So the microgrid is nothing but it's a combination of distributed energy sources. Distributed energy resources means it's like renewable and or non-renewable power plant actually. Renewable power plant if you take means solar power plant or either wind power plant or biomass or gas energy. So that are the renewable sectors. So that can be used in one of the resources. If you take another renewable means like diesel power plant, some other power plant as a power backup actually CHP. So these are the backup of the microgrid solution. And the next one will be the energy storage. So the energy storage is the energy that stores whatever the production in the daytime, the night time. If you use wind or solar, the energy stored in the battery. Whenever that other resources are not available, that time we can battery actually. So that's what the energy storage is in this actually. And this is independent power plant. You can be you don't need any like you don't need any substations. So independent have that. It's a kind of will be playing actually. In the microgrid, why the microgrid is important means in India we able to use only 20 to 50% of the renewable energy resources only actually. So if we use this microgrid, still the rate of renewables will be higher. So then and can be very less losses. In India, the power plant is compared, we are losing 8 to 10% of the transmission losses. We move with the microgrids, we can avoid the transmission losses. So that's what beauty of the systems actually. And that energy management systems, like depends on the load, it will give 24 by 7, 365 days. There is no power cut at all. Even the maintenance if you do, so that's the beauty. You can get the power 365 days. This is the micro basics. And next part, Suresh.
Yes.
Before going to detail, understand in the microgrid some points like what is kilowatt, kilowatt peak, kVA. So we'll go through this. Kilowatt is the power actually. So kilowatt is the power. It's a measurement of power. The power it will be it's like watts actually. So kilowatt hour is a measurement of energy. That means total amount of electricity you use. Like if you take an example, you are having 1 kilo, or you are having some 100 watts LED lights. Okay, that's a load. For that you need 100 watts power. Okay, that's a electricity rate of electricity usage. So that how much hours are running. For example, if 100 watts are running 1 hour, it will be 100 watt hour. So that's the units actually. That's what the kilowatt hour is, nothing but units, or it's a kilowatt hour. So that's the things. And next, kilowatt peak in the solar industry only there will be kilowatt peak. That is technically it's a kilowatt only, but for the solar industry the kilowatt peak will come because of the DC side. So we are using the solar system, which the output energy is the DC. Okay. So for the DC, it has to be mentioned as a kilowatt peak. Why the kilowatt peak is coming now? The panels and other panels will be coming with watt peak actually. 330 watt peak, 400 watt peak, 20 watt peak. Because in the higher variations, the panel will be rated as a 330 mean you will be getting 330 watt peak. So only that for industry only that DC side will be calling as a kilowatt peak. It will be kilowatt and kilowatt peaks are both are same. The difference between AC and DC, that's the peak we have mentioned here. And the next financial parameters. Okay, in financial parameters there are multiple parameters are there. We will just go through the three parameters now. LCOE and NLCOE. Okay, LCOE is nothing but levelized cost of energy. NLCOE is a normalized. Okay, so LCOE is nothing but cost of the power produced by solar over a period of time. It is likely. So if you install solar, will be 25 years warranty. Okay, for the 25 years period, how much cost of the power will be produced actually? So that's what the LCO will be calculated, levelized cost of energy. And the next part will be return of investment, ROI. This is ROI is between how much they invested. For example, if you take some 1 kilowatt, if they install like some 1 lakh rupees for the microgrid solution, within how much year they will be getting return. So that's what the return of investment and the tax benefit. So each for the commercial, you will be getting the tax benefit like AD, accelerated depreciation. So that will be the deep classes actually for that things and all. Next we'll go to the capital cost actually. So the capital cost is that also financial matter. So it will be the varies actually for microgrid. If you install renewable wind and like diesel, so the capital cost will be like higher or lower. It depends on the load and the customer things actually. So initially the cost of the capital cost will be, it may be higher or it may be lower. It's based on the customer. propositions actually. And the DOD is it's a functional parameter actually. In battery we call it as a DOD. Okay, so DOD is nothing but how much its percentage is discharged from the battery. Okay, it's nothing but fraction or percentage of the capacity which has been removed from the battery capacity. That's it, the DOD actually. As of now, there is multiple battery system out there like lead acid, flywheels, lithium-ion batteries. There is a lot of battery systems there. There is a problem with the DOD actually. If you take see, for example, if you install 1 kilowatt hour battery, 12 volt or 200 AH battery system, it will be never gives 100% efficiency. Okay, 100% output. The 50% will keep the battery itself. So even if you take the lithium-ion battery, our mobile chargers and all, it never gives. For example, they will mention 1000 mAh, 3.2 volt, 1000 mAh. So that kind of things they will mention actually. For that, it never gives that much of output for you actually. That the DOD is the depth of discharge. So and next will be the renewables. Okay, so that's what I already told. The renewables is 20 to 30% of the percent only we are using actually in the renewable. AMC is annual maintenance. So annual maintenance is nothing but it will be a predictive analysis, and the day to day they have to check on the site actually. It's complete the maintenance of the power plant. Next. So next will be Sudhir can take care that operation and philosophy.
Yeah, thank you, Santosh. And microgrid is this is a block diagram of microgrid plant. So we will have three different components. The important components we categorize that as reliable power source, where you can expect the power to be running whenever you need it. And there is energy storage system for the renewable power, because renewable power mostly it is variable across the day, and we cannot get the needed energy to meet the load demands. So we have three different components in this: a reliable source, an energy storage system, and renewable. At least one of each component, each of the components will be there in a microgrid. You can find the most common microgrids will be powered with diesel generator, with batteries or flywheel energy storage, along with solar PV plant or wind PV plant. This is the most common type of microgrids you will find. So renewable power depends, the plant depends on the site, whether we can put up the wind power plant, which requires 3 to 40 meter per second of wind on an average over the entire year, or a small hydro which requires water flow throughout the year, and solar PV plant which has a shadow, the site mostly which has no shadow problems and all. And most compatible, solar PV is the most compatible with all the things, and solar PV will be there in microgrid. Whenever you put a microgrid, the 90% probability that there will be a solar PV plant. And energy storage, as Santosh happened to say, there are many challenges in energy storage. The flywheel which cannot retain the energy for a long time, the batteries which deteriorate again and doesn't have the capability to discharge at the fast rate, and pumped hydro which cannot be made in a smaller sizes and which cannot respond to the load in a small fraction of time. And coming to this reliable power source, this reliable we can have this common question: when we can have a reliable power source, this can power the entire plant, why we need to go for other plants? So reliable power source, the diesel generator or the CHP plants or thermal plant, which has its own complications in environmental impacts, the cost, the operation, all these parameters. In order to avoid these things, we are going for renewable power, and we are using energy storage to make it a functional solution. So this particular microgrid controller, what it does is it studies the load and it switches between the energy systems, the reliable power source and the renewable power source. With a combination of both, it will address the needs of the utilities or the EV charging station, industries, rural electrification, anything. Because the present day EV charging stations are being a big key feature in Indian economy, and government is ambitious to put EV charging station every 3 kilometers in the highways. So we cannot directly grab the energy from the grid. that constitutes for a larger infrastructure than a microgrid. So distributed energy generation is a key where we can generate electricity at a lower cost, because diesel power plants or CHP plants, the like the per unit LCOE of the energy is very high compared to renewable energies. So on this entire thing, with the age of internet and remote monitoring, we can able to control this microgrid plants from anywhere across the planet. So let's look at each and every components in the microgrid from next. So renewable power source. The renewable power source mostly it will be PV. PV can range from few watts to megawatts of energy in terms of a microgrid. So there are plants which is more than few hundred megawatts, and gigawatt plants are ultra high capacity plants are being built across India, which ranges from 2.5 gigawatts, 2 gigawatts, 2000 megawatts in that range. But in a microgrid, we don't go for that kind of range. That huge capacities will be connected to the microgrid, because the calculation of having effective plant components in a microgrid is a key to have a better LCOE. And the wind power plant will use it from tens of kilowatts of turbines to megawatts of turbines, which is available so far. And the biggest challenge in this particular area is the wind and the area which is required. Wind turbine may seems to occupy a lesser space, but to there should be a very huge amount of area which should be left vacant around the plant to tap the wind energy efficiently. And small hydro, again the site constraints will come into play, because you need to have a very good water source to make a small hydro, and it should make sense to put up a power plant over it. So mostly it will be like an perennial rivers and the channels which will be diverted for other irrigation. Those places we can use the small hydro. I think the key features will be discussed with Santosh.
Yeah. Thank you, Sudhir.
Yeah.
So as I said, there is a two power plants, renewable, non-renewable. So now we talk about in renewable power source, what are the key features we have actually. So if you take fuel and consumable, so if you use the microgrid solution, so if you move with solar PV or like wind power plant, so the almost the zero fuel cost. Yeah, fuel cost will come reduce actually. So that you can be used maybe in future the electrical vehicles can be used. So the fuel gas will be, you can charge it from the solar PV side. Also, we are using solar as a backup power or wind as a backup power. The storage will be, so you are not depending on any diesel power plant. So that automatically that fuel cost will be zero, and it's a renewable power resource. So the renewable power source means you will be getting lots of benefits in the environmentally actually, like good air quality and water you will be getting good water quality, and the air will be purified, and the environment will be the green actually. So that will be the environmental impact. And if you always the zero waste disposal actually, and cost. Okay, if you go about the cost means initially that whatever the microgrid solution in the renewable sector, the cost will be higher. For the solar plant or wind plant or biomass or waste energy, the initial cost of the system will be high. Okay, so but that it will give this very least LCOE levelized cost of energy, and that the return of investment of the renewable will be within 3 to 4 years we will be getting actually. So that's the added advantage of the renewable resources, and we will be getting besides that the tax benefit, tax depreciation. So each, for example, if you there will be a GST for every power plant actually. If you buy any plant name, you have to pay GST certain amount actually. So that benefit you will be getting that actually. If you are if you are a commercial or industrial owner, if you have the GST number, so you will be getting that whatever the tax you put, you will be getting that till 3 years. So that tax benefit you have actually, and obviously the most beauty of the renewable will be the environmental impact. Okay, so that's it. The next part will be can you take Sudhir, renewable power source?
Yes. Yeah. So the other set of plants is reliable power source, where we can run it as long as we want and at the rate of power which we want. So this is basically will be backed by diesel generators, and presently diesel generators are being banned in India across NCR regions, and it is going to be across the country. So these diesel generators are soon to be replaced with gas powered gensets and CHP plants. This is a gas turbine power plant. So where this gas turbine power plant is a new thing, and it is coming into picture in a faster way, and there is so many innovations being made on this, and it is mostly like a portable way of power plants nowadays. So these CHP power plants are being taken into consideration for microgrids across the so many industries, and there is a very big problem with grid stabilization with the gas turbine power plants. And mostly other type, like for example, if I industry, for example, a large paper industry or a textile industry or a cement industry, steel, iron ore processing industries, these industries are energy guzzlers. They themselves happen to build power plants, coal power plants, or firewood power plants, biomass, biogas. All these type of thermal power plants, they happen to build it in their own wind city, and these power plants constitutes for a higher environmental impact, and this can be connected with microgrid with renewable energy and energy storage system to reduce their carbon footprint and improve their sustainable factor. And these plants, mostly these generators, we may get it from few kilowatt to few megawatts of energy can be made, and the LCOE of diesel generator is very high. Across out of all these three plants, it will be around 12 to 18 rupees per unit cost when we generate in diesel generator. And if it comes to CHP plants, it is much better, but we need to go on a higher megawatt. 50 or 60 megawatt plants makes sense, and rather than 5 or 6 megawatt plants doesn't constitute for much of a efficiency parameter. Even the thermal power plants at a smaller size, this doesn't make sense. So when we want to go for a smaller capacity, we still go with diesel generators, and larger capacities are very good trade-off in reducing the LCOE of the plant. This key features of this, I think Santosh will carry on with this key features. Santosh? Okay, so I'll just carry on with this. So the key features of the reliable power source is that we can vary the energy based on the load as we need, and the response is faster with this. And we can generate power round the clock. Any time of the day we can just generate it. Unlike solar power plant, it is just generating on the daytime, and wind power plants which just generates when the wind blows, and most of the time it will not be blowing, and the wind will not be blowing 24/7 in all the places. Only the offshore wind power plants will be able to generate that kind of energy. And the operation methodology is very simple in terms of diesel generators. The diesel generators is, since many of attendees are from mechanical, I think idling will be a very good reference point. So we just keep the engine at idle state. So that is the kind of generation we need to keep on the reliable power source. The reliable power source cannot be turned off completely. It should be running at a base load, which is usually around 30% of the plant capacity. So that is why there is a huge amount of losses occurs in the power plant. When the power plant is running at a rated capacity, the fuel is efficiently utilized and the energy is produced at the higher efficiency. When we are running at a base load, there is a huge amount of heat energy as well as the fuel which is getting lost due to energy which cannot be harvested. And the step ramping, we can immediately, like we just need 100 kilowatt or 200 kilowatt steps, we can easily ramp up the DC power plant or the thermal power plant, unlike the renewable power plant. We cannot ramp anything there. Whatever it comes, we may need to use it efficiently, or we can just waste that energy. And synchronization is very good with this power plants. Around 30% of the load response is being carried out without any controller in terms of DGs, the higher rated DGs in the market. So the cost will be lower initial cost. Initial cost of a DG plant or a CH2 plant, initially it is very low, but the cost keeps on increasing because we are going to use fuel here, and the fuel doesn't come free as in a renewable energy plant. This particular plant has a fossil fuel or a biomass as a continuous feed. So on which constitutes for higher LCOE, higher per unit cost on production. So the next key things is energy storage system. Since we happen to use renewable power in our microgrids, the renewable power generates energy mostly on the daytime and when the wind blows and the water is available. But the thing is, we cannot use this energy on the same time. We need to store it and then use it because mostly our loads will be in the evening. We come on and we turn on the lights and run all the things. So during evening, we cannot able to expect a solar plant to be producing energy. So what we do is we store that energy in terms of batteries, flywheel energy storage system. Flywheel energy storage system is mostly used to grid stabilization and pumped up hydro. In a utility scale, in a large scale, it is more like keeping up two reservoirs. One reservoir holds the water as a potential energy and it will discharge the water when the energy is needed to the grid. So the pump is basically a hybrid variety where the pump acts as a turbine as well as a generator. So which will pump up the water in the same reservoir which it came from. So this can be made to and from. This is something which is being invested vastly in many countries. And there are many other energy storage systems which are still under innovation, and government of India happened to give up a EOI recently on interest innovations in gravity based energy storage systems, just like the pumped up hydro or Swiss concrete blocks idea. So there are so many other things which government of India is willing to invest in terms of energy storage. Not just India, across the globe, energy storage is a key opportunity for every graduate. The key features. Santosh, you there?
Yeah.
Yeah. So the key features of energy storage, you can carry on with that.
Yeah, thank you. So for the battery, if your energy storage system, if you want to use me, there is a three important points there actually: energy density, DOD, and charge cycle, and cost. Okay, energy density is nothing but it will be you have to reduce the thermal losses. For example, if you keep the batteries above room temperature, the DOD will the efficiency of the battery will reduce actually. So you have to maintain the temperature for that kind of energy density we have to maintain, and the battery should be a recyclable actually. The recyclable, if you can take example lithium ion batteries. In lithium ion batteries there is lot of technology, new technology, lithium ion, lithium ferrophosphate. So that kind of new technologies are coming up actually. It's already installed some project as well, and DOD actually. And the DODs I already told actually. I don't want to again repeat. And the charge cycles, okay. The charge cycle, that if you want to buy a battery machine, that any mobile or any things, we have to see the what is the number of cycles they're giving actually. So number of cycle is nothing but discharge and charging. Okay. So how much times you are charging and discharging? That's charging cycles actually, and discharging cycles. So there is a two type of cycles is there. So there will be, for example, if you buy the lead acid battery, the charging cycle of it will give only 2 years. If you go with lithium batteries, it will give the 5 years. So because of that, of discharge. So that's a very important, and for charging and fast discharging actually. That's a important things. Now it has to be new innovations has to come actually, because if you take EV or solar, so that available time will be 3 to 4 hours only. So it has whatever the capacity, it has to be charged within that hour. So that kind of fast charging and discharging has to come in future actually. And obviously the cost of the battery will be higher, and it will be variable. The return of investment of the system will be variable and will be challenges. And for lead acid will be challenges for the AMC. for the lithium and some other recyclable batteries and all, that AMC charges is not much actually. It will be just free maintenance and replacement. Obviously, the recycle, if you use it, the replacement will be very easy. But even if you use like non-recyclable batteries like lead acid batteries and all, then it's a problem for replacement and AMC charges. That's it. Sumit, can you explain my controller? Okay.
Yeah. Yes, I'll go ahead with the controller. So the controller is the key component in any microgrid. The controller is the one which can able to predict the load when a load is being added. When we turn on a switch, there is added energy which needs to be met and which has to be produced by the microgrid. So this particular data is being collected from the utility side and it is commuted back to the grid. It looks at for the source, for example, whether a renewable can uh, address this load. If the renewable cannot address the load, it will check with the energy storage system which was provided for the instant response. And if the energy storage is not enough, that is when it will go to a reliable power source, a fossil power source, and it will give a command that we need to ramp up to address this need. So that is the kind of philosophy a controller works. So in order to make this controller work, there are many key features which the controller has to keep it constant. The frequency cannot be varied. The frequency should be kept constant across the energy generation and across all the plants. And the voltage system are rated for a particular system and it should be maintained too. We cannot vary the voltage in a larger factor. So that is where only the current will be varied. The energy in from a battery or the reliable power source, which can be ramped up to increase the current, the amperes of the plant, so to meet the energy needs. And this particular controller, what it does is it just predicts the load. It records the user analytics. What is the type of load he has constantly put on? Okay, for example, a person wakes up in the morning, uses his appliances, turns it all down, goes to office, comes back in the evening and turns on. This is a repeated cycle. So the controller measures this repeated cycle and predicts when energy surge can happen and it will ramp, it will give the feedback to the plant to generate energy and store enough energy in terms of renewable power to supply back to the needs. So, and even the energy prediction, for example, there is a cloud cover, a cyclone formation, the wind changes, irradiance changes, the temperature effects, all these things will be predicted with weather monitoring systems across the country. And with this weather data, what we do is we predict when a particular plant production will go down, when it will ramp up. Based on this data, we can easily switch on to the reliable power mode and we can save more amount of fuel which is spent in microgrids. And the switching source, I think Mr. Santosh will take on the switching source.
Yeah, sure. See that switching sources of the power variability of renewable power. So first I can explain you in the microgrid what are the components are coming. Okay, the first component is a distributed generation. As I said, distributed generation means either non-renewable or renewable loads, energy storage system, and static disconnect switch controller, point of common coupling and modes. So these are the things will come actually. So if you just the static disconnect switch, okay, so how to switch your sources, power sources from either solar plant to that loads or energy, so that we can go. So then can we go with next slide, remote monitoring?
Yeah.
Yeah. So that the Phovesto power is giving that remote monitoring solution, and So the telemetry will give the data for how to control other in the controller. It will be inbuilt for the remote monitoring solution. So that only give that feedback signal to how that load and how that power source I have to share actually. So we'll go with one by one. So the first things, if you take the solar photovoltaic modes, so if the customer if customers installed 1 kilowatt system on the solar plant, so it will be directly converted DC to AC. Then it directly goes to loads. If there is any no battery, first priority will set to that. Directly it goes to load actually. So that's the first things actually. That will call as a direct feed mode actually. Either it has to go to directly load, and the next part it goes to the charge the batteries. Whatever that the charging things is there, no, that it will be charge the batteries. Okay. And the next, for example, the charging is full and that load is also no load, then that power will be exported to the grid. So we can sell it to the EB, and they will give pay from actually. So that things will be the first mode actually. And the next will be the indirect mode. Okay. So the indirect mode is nothing but, as I said, before going load, it will be directly charge the battery, and the next extra power will be selling to the government actually. That will be that indirect mode actually. And the next will be DC mode actually. In the DC mode, so whatever the solar is generating, the power is there now. The solar generating power that directly used as a DC lighting, like DC LED lights, DC fans, or EV, if you electrical vehicles, you can directly charge. So that kind of, because in future the DCs are coming up actually because of very less consumption the DC lights are coming. So that's what the DC loads will be. You can be directly used when if you use DC mode actually. Obviously, that AC mode will be when the power will be converted DC to AC. It can be either it will be switching to either wind or biomass or hydro. It will be switching based on the customer inputs. How much is spending the cost actually. So obviously, if you want to use less cost, mean the cost, less cost, high cost. So that kind of cost things is there commercially we have to work out, and that depends on the load. Okay. So that part is there, and the next will be hybrid mode. Okay, hybrid mode is nothing but it will be working with, for example, the daytime. If the solar is generated, mean it will be directly going to the load. The extra power is stored in the battery, and that whatever that extra again extra will be selling to the government. So that things will come. For example, if everything is fine actually, for example, solar is not generating any power, the batteries are drying. So if you don't have any power, mean then the result will be turned on actually immediately for the backup power. So that's what that hybrid system is here working actually. And in this component, it will be in remote monitoring, data you will be getting, and any issues happen on the site, that it will be, for example, any inverter failures, the panels are not working. So that kind of alert you will be getting actually, and obviously the environmental predictions, like how much today it has to be generate power. So for example, if you have 10 units is daily consumption, if due to rain, it will be solar is generating only 4 units mean. So that automatically that AI will be programmed actually. If 4 units is generated from solar, the remaining 6 units or 2 units it will be getting from battery or any other resources actually. The kind of predictions that monitoring will give the data actually. And the next. Yeah. So applications. So we explaining the rural applications. So in rural, so if you take any villages, so there are still in India a lot of villages they don't have any power itself actually. Even the single power they can't run even the lights also. That's still India is there actually. So if you want to give power to them, it's the best solution for the microgrid solution. Because why mean they can get power for 24/7 and 365 days, as well as there is a and every all the homes can get power actually. They can use it whatever the loads use of microgrid they can get, and it will be the boosting the substation. It's like one substation for each village. So they will be getting directly power from the microgrid. Actually, each home, if 100 homes is their name, the 100 homes we can distribute the energy actually. So for 1 kilowatt, 1 kilowatt, that kind of they we can distribute, and they will get the power actually. They can run all the loads whatever in their home. So that's what in the rural electrification it can be used actually. And the other stuff Sudhir can explain.
Yeah. So microgrid is a plan which is mostly focused on defense capabilities of a country. So most armies in the planet has microgrids as a reliable source for them, because when we go on a mission, the fuel which has to be transported is at a greater risk. So with this particular microgrids, with the higher renewable penetration, we can able to achieve lesser fuel dependency, and which gives a very good advantage for the country's army, and as well as it is a reliable and efficient form of energy which can be got. And to be keen, like many people are very keen that like the solar PV plants which doesn't give any noise at all. There is zero noise at all from this power plant, and we can get huge amount of energy, which is a very good source of energy for defense sources. So these are being developed and for a rugged environment, easy deployment methods, and which can easily come in hand for disaster relief when there is a disaster happens, like for example the floods, the landslides, those places. This particular microgrids are very fast to deploy, and it can be scaled easily to a higher capacity. And with this remote monitoring and all the features which is being built inside with this grid, we can able to provide energy to that particular affected areas in a faster way, so that they can improve their moral support there, and helping the doctors on those places. And there has been an incident, the earthquake in Gujarat. People happen to use candles for making a surgery. So these are the places where we can use this microgrids and avoid such a situation, and provide a better helping hand for the people who go out there and carry out the rescue mission. So on remote energy, not just in the planet Earth. If you just see any satellite or any power space mission, there is no space mission absolutely without solar being powered in the present day. So everything is, even the Mars rover, everything is being powered by solar. And there is particular in this particular space missions, we use reliable source as RTGs, which is powered from thermal generators, electricity from a thermal generators. This thermal energy is being tapped from the radioactivity of materials like americium, cesium, plutonium, all these things. The New Horizons satellite, which was powered for and which happened to run for 15 years from NASA, that was working on the RTG based on plutonium and the solar energy. So all these space missions, the terraforming of other planets, and anyway, even in a ship, if you want to power a ship, you can go on. Like there is one ship which is completely powered by solar, and that particularly it has a microgrid with solar and waste to energy plant on board to it, and which runs across the seas, and there is no refueling needed for that. So these are the kind of applications which where microgrid is making the planet a better place to live in. So there are still some limitations in microgrids as well as the actual grid. So what we see is, like for example, when we have a power being given to a village, so every home today has a light running on it. So they increase their load. So from a light, they will increase a fan. A fan increases to a TV. A TV increases to a air cooler, air conditioner, everything. It keeps on increasing. So knowing the actual energy demand is a big um, challenge for the plant sizing in microgrid as well as microgrids. So, and one more thing is the usage. For example, when the person happened to put all the loads, heater, ACs, the geysers, all those electrical loads into a home, he uses it in the morning and he completely shuts it down and goes to office. So when the solar is being produced, solar, the renewable energies, and when the energy power plants can produce at very efficient cost, that time the person is not using the electricity. And evening at 6 p.m., 5 to 6 p.m., he will ramp up, he will turn on the lights, he will turn on the TV, the air conditioner, his gadgets, everything will be ramped up. Even the charging of EVs, it will be overnight. So it will be completely ramped up in the night. In the peak hour, the entire plant has to run at higher capacities. This has to be met simultaneously. Within an instant, the grid has to synchronize to this. This constitutes called a duck curve, which appears as a duck. So this duck curve is a big problem in energy industry for having renewables being utilized more. We need to, for example, when solar is being produced and it is utilized directly from the plant, the LCOE is lesser. When it has to be stored to a battery, it has to charge, and the losses during the charging, and when discharging again we lose some amount of energy, and this particular added infrastructure will all constitute for increased LCOE. So these are the problems which we face in the present day, and these are the places where the IoTs, the big data analytics, and those things, those data science, all these people which are coming in help to achieve this grid stabilization. So when there is a crisis, there is always a window for opportunity. So with this many crisis in microgrids, increasing the renewable penetration for more than 30% for a better LCOE is a big challenge today, and that can be met. And there are many researchers and career opportunities in increasing this grid stability, as well as the cyber attacks. So you can just Google now and you can see that cyber attack on power grid. You will get thousands of articles, thousands of cases which has been made. Recently in 2015, Ukraine grid was completely taken out with cyber attacks. So Germany, no country is being spared from cyber attacks from power grids. So these power grids are mostly monitored for the energy generation, all these things. You can remotely control to turn on the plant and turn off the plant. So that is the kind of flexibility which is being induced today in power plants. And when a cyber attack happens, they turned on all the plants, all the power generation. In 2008 in Germany, they happened to log into company's server and happened to turn on all their inverters. The entire one third of the country's generation was turned off. So that is the kind of attacks which is being done, and the need for this better firewalls and data protection. All these things is a big challenge in microgrid as well as in power regions. The remaining challenges, Santosh will carry on.
Yeah. What are the opportunities we can extend now? So if the renewables, so as of now in India, we have installed around like 370 to 400 gigawatt one. It may be renewable or non-renewable. Okay. In that renewable, we have only used just 17%. Okay. As of now, we have used only 17%. So there is a still opportunities for again the 15% we can. So we have the more space actually, so we can install more energy for the renewables. So that kind of beauty we have, and obviously for that the storage that it will be the low cost and durable, and the load variations and the synchronization. For example, you can easily synchronize solar versus DG, solar versus grid, solar versus wind, so solar versus battery. So you can easily synchronize. So you will be getting power within 24 by 7 actually. So that kind of very responsibility. So just in India, we are using around some 75% non-renewable sectors actually, non-renewable power. So you just think about the 75% of the non-renewable we are using. So how the environmental will affect actually. So if that's why the good opportunities once if you move with the microgrid solutions like villages, like hospitals and colleges, if you use the microgrid solutions, obviously we will reduce the environmental risk actually. And LCOE, we already told the LCOE will develop cost of energy, amount of this. So if we move with renewable sector, and it will be getting payback like 3 to 4 years actually. And you will be getting power without any interruption. It's an independent power source. So that's what the opportunities we have. So still we have that 15 to 20% we have opportunity to install going with solar actually, like renewable.
So this is up for the microgrid so far, which is being covered and only the basics of the microgrid. This is a whole new division of power plant engineering where we actually train people over a year of the time in individual power plants, sizing each and every plant sizes and how to configure the microgrid, how to decide what component to use, which particular protocol to use, because different companies has different protocols. There should be enough protocol. Like the microgrid controller has to able to utilize this particular data packs, and it has to process and it has to give back the control features. So all these things, giving the commands and ramping up the DJs, all these things is a big pack of training skills which has to be given for a person to be taken care of. So these are the things which we are providing from Phovesto 2, and this so far this covers the basics. So in Phovesto we have as a Phovesto team, we are a conglomerate team. We have multiple domains of industries which are being set up. So we are working on automotive industry where we are trying to make cargo handling vehicles based on electric vehicles and fuel cell vehicles, the charging stations, all these things is being worked on. And we have an industrial branch where we design, we engineer the plant, we create the entire plant layout, the plant sizing, the component sizing, the supply chain of a company, the financial management, and industrial management, the managemental concepts like Sigma. We have developed our own four quadrant systems, all these things which is being carried out in Force Industrial Solutions. And there is, as we happen to find out, there is a big issue in data security for a microgrid. We are working with a team of engineers in an IT segment where we are focusing on having this big data analyzed and creating a security and creating our own interface for energy grids. So on PyHub, so all these things requires the biggest thing. It's not the financial resource; it is the human resource. At the end, it is a human who creates a solution. So what we believe is we need to have a team. We develop a team. All this training activities, new member training, all these things is being carried out from our PyHub. So what we do is we provide industrial research. So most of our researches are funded from industries and mostly industrial requirements, which are being made as a project, and we make the minimal viable product, and we just learn the market and takes all those things, and we train the industrial people on the application. So it is not like, okay, we have a tool and based on that we develop something. No, we don't work like that. What we work is like we find a problem and how the problem can be solved. That is our way of approaching creating new things. And skill development for our own employees. Continuous learning is one thing we happen to study in our activities as a startup. So continuous learning is highly important for any person to be successful in life. So those are the things which we as Phovesto are doing. Please do explore these sites and please be in touch with us for the forthcoming webinars and those things. So please, I request everyone to give us the feedback on this particular presentation. This the feedback you can give it from the same registration link which you open to register for the webinar. The same registration link will be enabled within few minutes for a review for reviewing. Please do give us your valuable feedback so that we can improve ourselves for the next forthcoming plans.
Anybody have any questions?
Thank you for everyone. So please write out your queries and doubts to info@pyhub.com. or info@phovesto.com. You can still visit our websites and you can just post on the forums. You can chat with us. We are open to everyone who is willing to work with us and who is willing to create something new. We are with you, and the only thing which we care is to have a sustainable solution. If you are having a sustainable solution which creates a very good ecosystem of opportunities as well as resource management, we are open to all your innovations. I would request you to write it to us so that we can help you with the funding, the setting up the plant, all those things. So we'll be there with you. So thanks for Adhiyamaan College of Engineering, Department of Mechanical Engineering, and Mr. Shailin Jose, the coordinator. Very thank you, sir, for giving us this opportunity to present on behalf of you in this webinar. We look forward to provide more webinars to you, and we would like to be in person. We would like to conduct in-person seminars for you. And thank you. And I think we'll close it up for today.
Can you close it?
Yeah, I think you can, Santosh, you can just give a thank you note and we can close it. Yeah.
Yeah, thank you. If anybody having any question on these sections, today's sections, if anybody can raise the questions or whatever Suri said, and if anybody want to ask now, anybody can ask, or otherwise we'll end up the meeting. Thank you. Yeah, so can close the meeting. Thank you.
Yeah, sure. Yeah, thank you everyone. Thank you for reaching us. Yeah.